Today, I would like to discuss about gear, its principle, and working. First, let us know what is a gearbox. A gearbox is a mechanical unit or component consisting of a series of integrated gears within a housing. And inside the gearbox, we have the gears. A gear is a toothed cylindrical or roller-shaped component of a machine which meshes with another toothed cylindrical to transmit power from one shaft to another. It is mainly used to change torque and speed of driving shaft and driven shaft. There are many types of gears, and the gears are classified on the basis of construction of teeth, use, direction of motion transfer. But basically, it is classified according to the design of teeth. The different kinds of gears are the spur gear, helical gear, double helical or herringbone gear, bevel gear, rack and pinion gear, worm gear. Now, let us know the principle of a gear. A gear works on the basic principle that energy can neither be created nor be destroyed, but it can be converted from one form to another. As we all know, power is a function of speed and torque, or we can say that power is the product of torque and speed. So when we connect a small gear on driving shaft and a large gear on driven shaft, the speed decreases of driven shaft as per the unit rotation of driven shaft. We know that when we change up the gear, speed increases. But if we have to increase the power of the vehicle, we have to down the gear. For example, when you want to climb a steep slope, more torque is required. We have to down the gear for more power. That is, torque multiplied with speed gives power. So, as speed increases, torque decreases and power increases. The manual transmission of the gear works on the principle of gear ratio. That is, N1 by N2 equals T2 by T1, where T is the number of teeth and N is the speed. Now, let us study the working of a gear. A gear has an input and output shaft which is connected by a counter shaft. A 3-spin mechanism will look like this. It is clear that just by sliding the gear, we can achieve different transmission ratios. This transmission is more specifically called sliding mesh transmission. They are good for controlling the speed, but it has got some disadvantage. It is quite tricky to slide from one gear and get engaged to another gear. And this problem is solved by constant mesh transmission. Here, the gears are always in a mesh with a major difference. The output gear are loosely connected to the shaft. So, if we connect only one gear to the shaft at a time, the shaft will have the spear of the connected gear. With the help of a hypothetical connector, different gear ratios can be illustrated. For the first gear, the input speed by output speed equals 3.83. For second gear, it is 2.2. Third gear, it is 1.4. And the fourth gear, it is 1. It is interesting to know that for the fourth gear, the input and output shaft are directly connected. Here, the main shaft has a synchronizer teeth arrangement. This is a hub and it is fixed to the shaft. This is a sleeve and it is free to slide over the shaft. If this sleeve gets connected to the teeth of the synchronizer cone, the gear and the shaft will turn together. But during the gearbox operation, the shaft and the gear will be rotating in different speeds. So it is not an easy task. We use a synchronizer ring, and this synchronizer ring helps to match the speed of the gear with that of the shaft. The synchronizer ring is allowed to rotate with hub, but it is also allowed to slide axially. Before moving the sleeve, the clutch pedal is pressed. so the power flow is discontinuous. And when we move the sleeve will press the synchronizer ring against the cone. Due to the friction of force between the synchronizer ring and the cone, the speed of the gear will become as same as that of the shaft. At this time, the sleeve can be slided further and can be locked with the gear. Thus, the gear gets locked with the shaft. This is how you put the first gear, second gear, third gear,